Okay, let's take the next step here, and for this we are looking at the horizontal distance and the peak height of the football. So let me start with doing the peak height of the football. We just got done doing the time of flight. So we're trying to figure out what is the distance when it turns around at this point here. So it's heading up like this, and then it's turning around. So what is this peak height right here? Now, how would we go about doing that? Well, let's see, we just figured out how long it takes to get to the top. Since we know an equation that relates the velocity, the initial velocity, to the distance and the acceleration, we know the time, we can figure that out. So our other equation that we have, that is not written here, is that you remember x final is x initial plus v naught t plus 1/2 a t squared. So this equation is going to allow us to calculate the distance, and instead of x we're going to use y. So we're measuring from here y, so the y final, this total height from here to here, this height is equal to the initial vertical displacement, which is 0 in this case, so that goes to 0, plus the vertical velocity. In our case, we know it's 25 meters divided by the square root of 2, so we know we've got 25 meters per second in this direction, and we divide it by the square root of 2 to get whatever is, to get to this component here. Or another way of saying that is we take the sine of 45. So we know that this component right here is equal to the sine of this angle here, 45, times this part here. Let me do that on the next page. I'm going to attempt, no, let me just create a little box where I'll do it here. So let's see, how am I going to do that? Okay, so I'm going to say that I've got a triangle like this. This is a right angle. This is 25 meters per second, and this is 45 degrees. Now, I'm going to draw a similar triangle over here. It's supposed to be the same triangle. So this is supposed to be 45 degrees and an angle here. And I know that this is the square root of 2, this is 1, and this is 1. So in other words, I know that if I know any one of these, I can figure out the other ones. So, for example, I can say that this side is equal to the sine of 45, which is this over that, times that guy right there, 25 meters per second. This is equal to, this side is equal to, or this component is equal to the cosine of 45 times 25 meters per second. Now, the interesting thing here is that the sine of 45, you could see from this over here that the sine of 45 is 1 over the square root of 2. So the sine of 45 is 1 over the square root of 2. The cosine of 45 is also 1 over the square root of 2. So in other words, you end up getting that this component here on this side, this component is equal to 1 over the square root of 2 times 25 meters per second. Now notice that is equal to 25 over the square root of 2 meters per second. That's what we said in the beginning by just noticing that these are similar triangles. And we could have said, well, 25 is to the square root of 2 as this, let's call it, r. r is to 1. Or in other words, what we get there is that r is equal to 25 over the square root of 2 meters per second. That's minutes. So you can get this component r in any way, either by similar triangles, by using sine or cosine, or just literally using these 45, 45, 90 triangles and knowing that the values are 1, 1, and the square root of 2 on the hypotenuse. Okay, so here we go. We know that r is equal to 25 over the square root of 2. So if we go back to our problem, we remember that what we're trying to get here is the peak height of the football. So we're trying to use our equation, this one down here, to solve that. So the x final, or y final, this peak height, y final, is the y initial 0 plus the initial velocity, which we now know is 25, which up is 25 over the square root of 2, times time. We know the time is 1.8 seconds, plus 1/2. Now the acceleration we know is downward, so that is a negative 9.8 meters per second squared, times 1.8 seconds squared. So let's go ahead and write all that down. Y final is equal to 0 plus 25 meters per second over the square root of 2, that's the velocity, the initial velocity, times the time, 1.8 seconds, minus 9.8 meters per second squared over 2, times 1.8 seconds squared. Okay, so I've kind of carried through all the units here because I want to show how they end up canceling each other out. So this second is going to cancel the second. We're going to have meters, and that's what we're looking for. Y, we're looking for meters. And over here we've got second squared. That's going to cancel with this second squared. So we will also have meters there. So we've got now YF is in terms of meters is equal to 25 times 1.8 over the square root of 2. That is about, that's about 30, isn't it? Okay, let's try it out. 25 times 1.8 divided by the square root of 2 is 32. It's 31.8. 31.8 meters minus 9.8 over 2 is about 4.9. Roughly 5 times 1.8 squared. Oh, what is that? 5 times 3. This is about 13, but let me do it here. 4.9 times 1.8 squared. Oh, I had that wrong. Is 15.9. So our 31.8 minus 15.9 is meters. 15.9. Well, that is just about half. It is 15. Is that right? It is. It's half. So we've got the final height in meters is equal to 15.9 meters. Of course, we only had two significant figures, so we would call this 16 meters. That is the peak height.